Good day. So welcome to the show of Massive Quality Mathematics. So today I want to take you through integral calculus, specifically focusing on integration using U-substitution. So integration using U-substitution is a very powerful technique in integral calculus because it enables us to integrate some large class of functions. So I want to take you through several problems, doing them step by step, showing you how we integrate using U-substitution. So without wasting any time, let's get into it. So let's evaluate the following. So one, the integral of x squared into 1 plus x cubed to the power 1 over 4 dx. So this one, you can see that this, if we let this guy to be u, then we can be able to differentiate this guy and get some x squared where we can substitute. Let's do it. You see it, if we let u to be equal 1 plus x cubed, so du over dx will be equal to 3x squared. So 1 over 3 times du will be equal to x squared times dx. So we are making this transformation because we don't have a straightforward formula to integrate this large class of functions. So we're making this transformation so that we can be able to simplify the problem. So then we'll have integral of x squared times 1 plus x cubed to the power of 1 over 4 dx. So this will just be equal to integral. So you can see that x squared and dx is 1 over 3 du. So and this one is u. So this will be u to the power of 1 over 4 times 1 over 3 du. So this one is a constant. 1 over 3 is a constant, so we can take it outside of the integral sign. So this is just equals to integral 1 over 3 outside of the integral sign, u to the power 1 over 4 du. So now we want to integrate now with respect to u because we have simplified our problem. We have made this transformation in order to simplify it to integrable part. So now let me erase here for the sake of space. So this will be equal to 1 over 3. The integral of this, we can use a very simple power rule. This will be u 1 over 4 plus 1, which will be 5 over 4 divided by 5 over 4. Then plus a constant, because when we're integrating, we are free to add a constant because antiderivatives or integrations, it's not unique. So this will be equals to, then when we do this, then we have 1 over 3 times 4 over 5 u to the power 5 over 4 plus c. So this will just be equals to 4 over 15 u to the power of 5 over 4 plus c. So this will be equal to, remember, our u is something. Our u is 1 plus x to the power 3. So we need to return back that 1 plus x to the power 3. So the final answer will be 4 over 15 into 1 plus x to the power 3 to the power 5 over 4 plus a constant. So this is the final answer. So this is how we do it. So let's go to the next problem. So let me erase this. Second problem. So let's go to the second problem. So let's have integral number 2 x plus 3 divided by cube roots of x squared plus 6x dx. So let's see how we can do this one. So you see, what we have to do is to check if you can see, if you can let this to be u, then when you differentiate that u, you will get 2x plus 6, where you can be able to take out the common factor to be x plus 3. Then this x plus 3 dx can be something in terms of u. So let's do this properly. So if we let u to be equal to x squared plus 6x, so du over dx will be equal to 2x plus 6. So this will be du equals to 2 into x plus 3. We take out the common factor of 2 dx. So when you take this to this side, this will be 1 over 2 du equals to x plus 3 dx. Can you see that this x plus 3 dx is here? We can be able to substitute it by 1 over 2 du. So that's what we are really doing. So now this is the transformation. So now let's solve now. So this will be the integral of x plus 3 over cube root of x squared plus 6x dx will just be equal to this guy, and this one is 1 over 2 du, but this one is 1 over cube root of u times 1 over 2 then du, because this one is u and this guy is 1 over 2 du. So proceeding, let me erase this part because of the space. So this will be equal to, we can take 1 over 2 outside of the integral sign because it's constant. So this one can be written as u 1 over 3. When you convert this said form into the exponent form, so then this one can be written as 1 over 2u to the power of 1 minus 3 du. So this is just equals to, so what is this equal to? This can be we can use a normal power rule. We can add 1 that side. So it's minus 1 over 3 plus 1, which would be 2 over 3 divided by 2 over 3 plus a constant. So when you integrate that, you get that. So this will be equals to, this will be 1 over 2 times 1 over 2 times 3 over 2 u 2 over 3 plus c. So this is just equals to 3 over 4 times u to the power 2 over 3 plus c. But mind you, u stand for something. U stand for x squared plus 6x. So we return back the owner. This will be 3 over 4 times x squared plus 6x to the power 2 over 3 plus a constant. So this is the This is the final answer. So this is how we do it. So now let's go to the next problem. So screenshot it, then I will erase this. So we can have a problem. It's number 3. Integral of sec squared x plus 1 times square root of 1 plus tan x plus 1 dx. You can have this kind of problem. So you can see that if we let this guy to be u, then when we differentiate this tan, we get sec squared of something. So if we let u to be equal to 1 plus tan into x plus 1, so when we differentiate u with respect to x, we get sec, because this is 0, sec squared x plus 1. So then this means that du equals to sec squared x plus 1 dx. So then you see sec squared x dx will be replaced by just du. So then this will be integral. This will be integral of sec squared x plus 1 times square root of 1 plus tan x plus 1 dx will just be equal to integral, this one will be square root of just u, then times du, because this part and this part is du. So then this will be equals to integral, this will be u to the power 1 over 2 just du, which is equals to, we use a normal power rule, we add 1 to the exponent divided by that exponent, which will be u 3 over 2 over 3 over 2 plus a constant c. So this one will be equal to it will be 2 over 3 when you simplify that, u to the power 3 over 2 plus a constant. When in place of u, you put this so that everything would be terms of x. So to do that, let me erase this part. So then this will be equal to 2 over 3. Remember u, it's 1 plus tan into x plus 1 all to the power 3 over 2 plus a constant c. So that's how we do this one. So let's look at another problem again. So let's look at another problem. Number 4. So we have integral square root of x squared minus 2x to the power 4 dx. So here you can see that if we make our u substitution, if we let this one to be u, then we have something in terms of u and in terms of x, and we cannot be able to get rid of x. So what we have to do is to take this x squared as a common factor. Here there is a common factor of x squared. We're left with 1 minus 2x to the power 2 then dx. So when you do that, you know that we can use some power rules. This will be square root of x squared times square root of that one, which will be x square root of 1 minus 2x squared, because square root of x squared is just an x. It's just x. So this is times dx. So then if we can let now u to be 1 minus 2x squared, then we can be able to differentiate with respect to x. and we'll get minus 4x. Minus 4x because the derivative of the derivative of a constant is 0, and the derivative of minus 2x to the power 2 is just minus 4x. So then this will be just minus 1 over 4 du equals to x times dx. So that means where there is x dx, we're going to put minus 1 over 4 du, and where there is 1 minus 2x squared here, we're going to just put u. So this becomes symbol. This is just equals to. Then this transformation is made so that we can write this in a simpler form. In terms of u, this would be square root of just u times minus 1 over 4 then du. But minus 1 over 4 is a constant, so we can take it outside of the integral sign. So this will just be equals to minus 1 over 4 integral of u to the power of 1 over 2 just du. So then we can just be able to implement the power rule to integrate this one. So so this will be as follows. It will be as follows. So this will be equals to minus 1 over 4 u. 1 over 2 plus 1 is just a 3 over 2 divided by 3 over 2 plus a certain constant. Because don't forget that constant. We add a constant after integrating. So just immediately after integrating. So this will be just minus 1 over 4 times 2 over 3 times u to the power 3 over 2 plus c. So this will just be equals to this remain with 2 minus 1 over 6 times u 3 over 2 plus a constant. Remember, we don't leave the answer in terms of u because an original problem was in terms of x. So we need to place everything in terms of x. Remember, u stands for something in that particular problem. It stands for 1 minus 2x squared. So this will just be equals to minus 1 over 6, 1 minus 2x squared to the power of 3 over 2 plus c. And this is the final answer. If you want to place it in terms of said form, then you can just convert this nonsense to be square root of 1 minus 2x squared to the power 3. That's when you want to write that thing in a said form. So we can look at another example again, the last example of the day. The last example of the day, it involves trig ratios or trig function. So we have integral of sine 2t plus 1 over cos squared of 2t then plus 1 dt. Yeah, this is in terms of t. Yeah, it can be in terms of any variable. Now, you see, this guy, it is just like cos of t 2t plus 1 all squared. It's just like this. So if we let this guy to be u, let's do that. So if you let u to be cos of 2t plus 1, then du over dt will be just we get a negative sine 2t plus 1, but because we're using a chain rule, we need to also differentiate this inner function or the inside function, which will be just 2. Then the du will be minus 1 over 2. This will be just minus 1 over 2 du equals to sine of 2t plus 1 then dt. You see, here, this guy, here, we're going to replace by just minus 1 over 2 du. And this cos 2t plus 1 all square cos of 2t plus 1 are going to replace by u. So this will be integral, will just be equal to the integral what is this guy? So this is to be 1 over u squared times, what is this guy? Negative 1 over 2 times du. So this just equals to, and we can take this minus 1 over 2 outside of the integral sign. This will be 1 over u squared du. So then we can write this as u to the power minus 2 times du. So this will be just equals to minus 1 over 2 times u. We add a 1 to the exponent to be minus 1 all divided by minus 1, then plus c. So this will just be equal to 1 over 2 times 1 over u plus c. Remember, we need to write everything in terms of t, because the original problem is in terms of t. So this one will be equals to 1 over 2 times 1 over cos 2t plus 1, then plus a constant. So we can write the final answer as 1 over 2 cos 2t plus 1 plus a constant, and this is the final answer. So this comes to the end of our session or our class. So yeah, this is how we normally integrate using U-substitution. So thank you very much for going through this video, and I hope it really helps a lot.